As we all know, the internet has created a whole new way for people to communicate with each other. Now, using my smartphone, I can get directions when I travel, share photos with my friends, watch videos of grumpy cats, and easily hack my way past security into, well, never mind that last one. Now our electronic devices can use the internet to communicate with each other too, and I'm guessing they'd be a bit more responsible with it than we humans are. When it comes time to create devices that take advantage of this new Internet of Things, whether we're designing home automation, wearable technology, or new industrial controls, we need a processing platform that can help us address the complex design challenges posed by these smart, connected devices. Hi, I'm Amelia Dalton, host of Chalk Talk. Today I'm talking with Andreas Eieland of Atmel about the exciting new SAM D20 Cortex M0 Plus family. This flexible, low-power microcontroller family packs some pretty interesting capabilities that might just be what you need for your next connected design project. Before we get started, I want to remind everyone that you can click on that Download Now button below your player. There you can download a free white paper that further expands on this topic. Thanks so much for joining me today, Andreas.
Oh, thanks for having me, Amelia. Really appreciate it.
So you guys have been around for a while, right?
Yeah, some people will say we've been around the block not only once, but even twice. So Atmel was actually founded back in 1984, and we've been making flash-based micros from the mid-90s, starting with 8051s and our own proprietary 8-bit AVRs, and the last 17 years we've also been doing ARM micros.
Wow, okay. So everything I've got today is connected, right, Andreas? Same for you. My fitness monitor is connected to my phone, which is connected to my cat's food dish.
Yeah, everything really is interacted today, and this is some people say the era of the Internet of Things.
Yeah.
So your fitness monitor is connected to your phone, your industrial application has a diagnostic unit you can look into, your smart energy meter at home does the profiling, we have wearable electronics picking up, we have these fit bands, the fuel bands, you have smart watches. Everything is getting smarter and more connected.
Yeah.
And all of these applications really have three components. They have a sensor or an actuator. They have a connection link, either wired or wireless. And in between the connection link and the sensor, there is a micro.
Yeah.
And our new Cortex M0 Plus product line, the SAM D20, is really designed to be this glue between sensors and connected systems.
Ah, okay. So back up just a second. Tell us where SAM D20 fits into your existing products. You guys have been making microcontrollers for a long time.
Yeah, we have. And if you look at the big market today, so 4 and 8-bit, which is basically just 8-bit, is around a third of the market. 16-bit is around a third, and 32-bit is around 40%.
Okay.
And if you look at the products we've had in the market today, our 8-bit AVR product line covers almost the entire 8-bit market, except for the very low end of the 4-bit.
Okay.
But we also fight a lot against PIC-24s, MSP430s, so we know we're in the 16-bit market with our 8-bit products as well. And then on the higher end side, we have our Cortex M3, M4, and our AVR32 UC3 product line, stretching all the way up to our Cortex A5 high-end MPU product. We're well versed in the 32-bit space as well, also taking some of the high end of the 16-bit space with those products. Now, if you look at the SAM D20, the SAM D20 expands our portfolio to address a lot of new applications that we didn't fully address before.
Ah, okay.
And if you look at this figure, you see that we actually overlap both on the low end towards our AVRs and on the high end towards our existing Cortex-M products. And this is fully intentional. We do not want to force people to do a platform change or to force people into a decision. If you want to be with an AVR and have an upwards migration path in performance flash, I want you to be able to do that without having to change around things.
Right.
Same if you're on an M4, we want to give you a path there. But we also want to make sure we have a really wide portfolio on the Cortex M0 Plus.
That makes sense. So I think I understand, Andreas, where the SAM D20 fits in the grand scheme of things. But Did you guys license the core, or is there some Atmel DNA in there as well?
Oh, that's a good question, Amelia. So the Atmel SAM D20 really combines the best of Atmel MCUs, Atmel microcontroller know-how with the ARM Cortex M0 Plus CPU.
Okay.
From the Mega AVRs, this really is the bread and butter of AVR.
Okay, yeah.
So we took the ease of use. It's one of the big things on the Mega AVR. And ease of use is much more than me telling you it's easy to use and trying to convince you to pick up a dev kit.
Right.
It's making sure that peripherals are easy to use, that the guy who writes the UART code makes sure that the initialization is not done over 12 different registers.
Right.
It's making sure the datasheet is factual and easy to read without too much marketing fluff in it.
Yeah.
It's making sure the tools are easy to use. And it's making sure that our field engineers and tech support people are well trained. So when you reach the point in your project where you don't find a solution, you can reach out to someone and they'll be able to help you quickly and efficiently.
Nice.
Part of easy to use is also to have a strong tools offering.
Sure.
5-6 years ago, we launched the X Mega. So the X Mega really was the second generation AVR. So in meetings with engineers like you, we actually take notes when people say, you know what, the Mega AVR is perfect for me, but I'd like to see this.
Right.
So we took all this feedback and built the X Mega. And some of the X Mega features are really powerful and efficient. And they've migrated to many other product lines.
Okay.
One of them is the event system. The event system is a system that allows peripherals to cooperate without using any CPU resources.
Wow, okay.
So if something happens in one peripheral, it triggers a reaction in another peripheral.
Cool, okay.
The way I think of this is like a reflex in your body.
Yeah.
So if you're in the kitchen, you accidentally lean on a hot plate, the signal goes through your arm in the nervous system, through the spine, and then to the muscles, you pull your hand away.
Right.
That's the event system. A split second later, you feel the pain. That's the interrupt system. So that really is the difference here. And the event system, as I said, was built for the X Mega, but now we even use this on our Cortex M4 products.
Ah, okay.
That's how efficient it is. It offloads the CPU. It gives you guaranteed timing. So it's very good for systems with real-time constraints, security constraints, things like this. To the D20, we also took the analog performance from the X Mega.
Okay.
12-bit really is the new 10-bit. That's where it starts for a baseline product. And we took the timer counter structures. They are flexible. So all the timers on the SAM D20 are 16-bit.
Okay.
But one 16-bit can be split into two 8-bit.
Ah, okay.
Or two 16-bit can be combined into one 32-bit. So really giving you the flexibility to mix and match.
Yeah.
Then from our Cortex M4, SAM4 family, and our UC3 products, we took some other peripherals. Especially I want to mention the peripheral touch controller.
Okay.
We acquired a capacitive touch sensing company a couple of years ago, and we've been doing a lot of work, especially on our touchscreen side. There's also a good trickle-down effect to buttons, sliders, wheels, proximity.
Yeah.
And the latest generation of this is the touch controller that we've embedded in the SAM D20.
Ah, okay.
Actually supports up to 256 buttons without using any external components.
Wow.
So capacitive touch sensing is an active sensor. You have to drive it, you have to filter it and listen to it.
Yeah.
But both the driving of the sensor and the first level filtering coming back is all done in hardware by the touch controller module.
Ah, okay.
So you don't have the CPU overhead often seen with just pure software implementations.
Yeah.
Another thing we took from the SAM4L is the sleepwalking. The sleepwalking is a feature that builds on the event system.
Okay.
So not only do we allow peripherals to cooperate, we also allow them to make decisions without using the CPU.
Ah, okay.
So it's a good way to reduce your wake-up frequencies, further offload the CPU. And another nice feature of the sleepwalking system is that any peripheral can request a clock source. So even if the device is in the deepest sleep mode, a timer counter can still have the branch of the clock tree running down to it being clocked, and you can have a PWM signal running even in the deepest sleep mode.
Wow, okay.
Then the last thing is we have something called the Atmel software framework, which was both for the UC3 and the SAM4. We had this from the get-go, and that's what we're doing for the SAM D20. Atmel software framework, or ASF as we say, is a new way of distributing source code.
Ah, okay.
Previously, you had to go to 3 different PDFs, copy-paste the code, and hope that it worked together.
Right.
The ASF is our way of distributing digital content. Source code, low-level drivers, examples. You select what you want, Atmel Studio puts it together for you. It also has a hardware abstraction layer. So what you make for the SAM D20, you can reuse for the SAM4L.
Nice, okay.
The last piece of the puzzle is what any semiconductor vendor can get if they send a big enough check to Cambridge.
That's right.
The benefits for you is, of course, that the Cortex M0 Plus, it's a widely adopted CPU. So if you want to make a platform decision based on the processor and not on the vendor, which we don't like, of course, as a vendor, but it's flexibility that many engineers want, it enables that. The Cortex M0 Plus also have some good benefits over the M0. So Atmel did not go with the M0. One of the ones I really want to highlight is the single cycle I/O access. AVRs and other 8 and 16-bit vendors have had this always. And we know that as much as we talk about high-end peripherals, we talk about 12-bit analog, there's so many customers out there that bit-bang a proprietary protocol, or they do some bit manipulation to control peripherals. Having a fast and deterministic I/O pin access is really important.
That's true, yeah.
The result of all this, mixed in with some proprietary processes to make sure we get the power consumption where we want it, it's the Atmel SAM D20.
Fantastic. Okay, Andreas, I'm ready. Let's dive down into some details.
Okay. The SAM D20 can operate up to 48 megahertz.
Okay.
Even from internal RC oscillators. It does it with a 0 weight state SRAM.
Okay.
And it's only a 1 weight state flash if you're running at the higher end of the voltage range. For the SAM D20, we're just not launching one device. We're launching a family of products. All the way from 16K 32-pin, all the way up to 256K of flash in a 64-pin package.
Okay.
And it's a really good flash as well. So these devices, they have a 0 weight state SRAM, and the flash has a minimal amount of weight state over frequency and voltage.
Ah, okay.
And even these weight states, they don't give you a big hit, because Atmel, we have a smart caching system between the flash and the SRAM that's completely invisible and transparent to the developer.
Very cool, okay.
But it minimizes any weight state that you'll see. Some of the differentiating features I want to highlight, it's the event system that we already talked about.
Yeah.
And we have a brand new module called the Serial Communication Module, or SERCOM for short.
Okay.
So this is a module that can be configured from software to act as a I2C, UART, USART, or SPI.
Ah, okay.
And every device have multiple SERCOM modules. If you in your application need 5 UARTs, you take a device with 5 or more SERCOMs, you configure them to be UARTs, and you have what you need. On the traditional micro, you need to buy a device that have 5 UARTs, but also 5 SPIs, 5 I2Cs.
Right.
So you end up paying for 10 serial units you're not using.
Yeah.
The SERCOM module really gives you the flexibility to find the perfect fit for your need.
Very cool.
Another nice thing with the SERCOMs is the SERCOMs support pin multiplexing.
Okay.
So if you have other constraints on your boards, you want to have other components placed in a certain way, you can optimize the pin out of the SAM D20. So you avoid vias, you can avoid some gapping 0 ohm resistors. And I even have a customer that was able to avoid a complete layer of their PCB layout with this.
Wow.
Yeah, that's huge. So both saving real estate and making layouts easier.
Yeah.
We talked about the touch hardware engine. And another nice thing we have on the analog side is we have a 12-bit 350 kilosample per second A to D converter with gain stages. It also has hardware support for oversampling and decimation, so you can go all the way to 16-bit resolution.
Ah, okay.
And then we have a 10-bit single-channel DAC as well for those times you need to not only take analog in, but also put analog out.
Yeah. Okay, so Andreas, a lot of engineers find 32 bits harder to use than those good old 8 bits. How do you get around the ease of use question?
The way we address this is it came natural to us. Because what we did with the SAM D20 is we mixed our 8-bit MCU designers with our 32-bit MCU designers. And especially on the peripheral side, we used a lot of our 8-bit know-how. So of course we turned it into 32-bit registers to make it more efficient to write.
Yeah.
But we made sure it stayed easy to use. As we touched on earlier, don't use 12 or 15 registers to get the UART working.
Right.
Make sure the bit to enable the SPI has the same naming and the same placement in the register as the bit you use to enable a timer counter. So you don't necessarily have to read the entire datasheet chapter.
Right.
We also make sure the datasheet is easy to read, that our example code is easy to read.
Good.
We provide free source code and all low-level drivers.
Nice.
In Atmel Studio, there's more than 1,600 example projects now, to give you an idea.
Wow.
We also have around-the-globe tech support, regardless of who you are. If you're a student doing your first SAM D20 project, you'll get a reply within 48 hours.
That's fantastic.
And we have Atmel Studio. Atmel Studio is our integrated development environment. It's the platform for everything we do on software. Atmel's a silicon company. we don't sell software. So we give software away for free. Makes it easier. What you do is you can download Studio 6. It comes with a software framework, which is all the low-level drivers, all the source code. It also comes with something that we call the Atmel Gallery.
Okay.
And Gallery, that's where we enable our third-party vendors.
Oh, okay.
Traditionally, if you buy an RTOS, you need to find a way to get the RTOS to work with your compiler, to work with your IDE, to work with the other source code you have for low-level drivers.
Right.
But the Atmel Gallery really works kind of like Apple's App Store.
Okay.
To get into the gallery, we validate that what you sell work in our environment and work with our software.
Wow, okay.
So you don't have to put the pieces together yourself, you just get it.
Nice.
And another thing to make it easy to use, we talked about connectivity when we started this talk. It really connects well to Atmel's wireless solutions. Both our RF, Zigbee, 6LoWPAN, RF4CE solutions, and our recently acquired Wi-Fi solutions.
Very nice. Okay, Andreas, sometimes we'll design in a device, and for the next project, halfway through the darn thing, I realize that I've made an expensive mistake. I need more pins, more memory. How hard is it to migrate up?
So what you're talking about there is one of the most common mistakes we see people do in all projects, and it's a mistake that it's healthy to make. It's very hard to have 100% aim on what your final product is going to be when you start it.
Right.
Marketing increases the spec. You find a more optimized compiler or need to support one more language on your screen.
Right.
The SAM D20 was made with this in mind, and that's something we have from the Mega AVRs and from the X Megas. We want to have easy migration, not only across memories, but also across pinouts. All the SAM D20s are actually hex compatible.
Oh, okay.
Of course, you have to make sure you don't try to write to a pin that's not there on a smaller package.
Right.
But as long as you stay within the peripherals and features available, they're hex compatible. They're actually also upwards compatible to our SAM4L family.
Oh,
so
okay.
That's a Cortex M0 low power product. So if you need more memories, if you need more peripherals, if you need lower power consumption, we have a path there. Another thing that I want to emphasize here that you will enjoy is if you look at the 32, 48 and 64 pin packages I have on my drawing here, if you look at the green analog pins, they're all on the bottom side.
Yeah.
If you look on the reset pin, the power pair and the core voltage on the left side, they're all on the same side. These packages grow in I would say, a organic way.
Ah, okay, right.
So if you're using the TQFP packages, you can actually lay out these footprints inside of each other.
Oh, okay.
So what this means is if you make them memory change up or down, that's hex compatible. If you need to go between pinouts, of course they're not drop-in compatible, but it's a minimal change to your hardware layout to move either up because you need more features or to move down if you find you can reduce your cost.
Very nice. Okay. I've picked my part and I'm ready to roll, but where exactly do I start? I assume there might be some dev kits and tools available?
Yeah, the best way to get started is to download Atmel Studio. As I said, it's free. It supports not only the SAM D20, but all of our Flash-based products. The good thing is that inside Atmel Studio, if you go to the gallery, there's a 3-month free cycle-accurate chip and peripheral simulator from one of our partners.
Nice.
So that means even before you have the first silicon in hand, you can try to write some code, evaluate, see, there's probably a crux or a hard point in your application. It's like, does this device really do what I need it to do?
Yeah.
So you can do that, download, get started in a handful of minutes.
Okay.
Then you can start looking into perhaps building more of an application. And what many people do, and what I do especially for my hobby projects when I don't have the time to write everything from scratch, is I go into ASF, I find a project that's there, that's close to what I need,
Yeah.
and I start just altering that to see kind of the proof of concept stage.
Nice.
And then if you move into more production type project, you'll look at the peripheral drivers, you'll use the hardware abstraction layer, you'll use the communication stacks for the RF if you need that, and all those components are in there. But then talking about software is, at least for me as a microcontroller guy, software only gets me that far. I want to play with hardware, I want to see that first LED blinking.
Right.
And the kit we really recommend there is the SAM D20 Explain Pro.
Okay.
So this is a slightly larger than a credit card sized board. It's based on the largest product in the SAM D20 family, the 64-pin 256K, which really is a good device to base it on because, as we said, they're hex and pin compatible. So you start with a large one, you find out how much memory do I use, how many Serco modules do I use, and then you find the product you lay out for your first PCB.
Right.
So the SAM D20 Explain Pro, it's all you need. You plug it into your computer, and it comes with an onboard programmer and debugger. So you can reprogram, you can debug, and the day you build your own board, you can actually use the D20 Explain Pro as a debugger to your external board.
Awesome. Okay.
What we've done is the SAM D20 is a general purpose device. I have some ideas of what people will use it for, but I have no scope of what everyone will use it for. So instead of tying down all the pins to components on the board, instead we made expansion headers around the edges. Either you can buy some boards from us, you can buy boards from third parties, or you can connect your own Vero board, your own breadboard, or your own PCB to do your early prototyping.
Very nice. Okay, so the big question here, Andreas, why are you doing all of this?
In order for Atmel to be successful, our customers need to be successful. And for our customers to be successful, their engineers need to be successful.
True.
So we really made a device that we want to be the enabler for engineers to be successful, to enable new projects, and to do it the way you want it to be done.
Yeah.
What is it developers like you want? Well, everyone is measured on hitting their schedules. Even the people working at Starbucks get timed on the time they make a coffee, right?
True, yes.
And the SAM D20 is made with ease of use in mind, as we've talked about in detail. And the ASF really provides you a head start on the development. You don't have to dive into the bits and the bytes from day one. You have a platform to start on.
Yeah.
Another thing that everyone has to do is they have to differentiate their products from what their competitors are doing.
Very true.
Just like I have to do on the silicon, you have to do on your end product. And the SAM D20 has several innovative peripherals that allows you to reduce the form factor, add functionality, reduce power consumption, and extend battery life, all these kinds of things. At the end of the day, it comes down to cost. It doesn't help having the right product at the right time if your price is wrong.
True.
Things like the Circom module increases the fit, reduces the cost of the PCB. We're launching 14 different products in this first family of the Cortex M0 Plus powered products. And of course, I'm not launching a product into an established market without being cost competitive. And it really should give you the perfect fit for your product.
Fantastic. Okay, Andreas, this was a little bit to wrap my head around. Can you recap a little bit?
Yeah. In the SAM D20, we combine the best of AVR with the best low-end 32-bit core that's available out there. It enables smart and connected devices, wireless solutions, human-machine interface devices, connected devices in other ways. It's a device family with a rich feature set, with intelligent peripherals that can cooperate using the event system and sleepwalking. And it's the new Circom module that really gives you the flexibility you need. And then we've done everything we can to make sure it's a device family with the shortest possible design time. Powerful development tools where the software is free, the kits like the D20, which will actually, for those of you who participate and listen to this call, as long as this Chalk Talk is active, we'll actually give away some kits occasionally to those of you who complete the survey. For those of you who are not lucky enough to get some of those kits, you can go to store.atmel.com, you can go to DigiKey, you can go to any other of our distribution partners.
Okay.
And that kit is priced around $39.
Okay.
And then, last but not least, we have the migration story. If marketing comes and hits you with more features, you can migrate up. If you've been burned by that experience in the prior project, and you start with a really large device, towards the end of the project, you can say, I can go down in memory and or pins and save some cost.
Nice. Well, I think that's all I have time for. Thank you so much for joining me today. It was a pleasure speaking with you, Andreas.
Okay, thanks, Amelia. Bye.
And before we go, don't forget to click that Download Now button below the player to download a free white paper that further expands on this topic. For Chalk Talk, I'm Amelia Dalton. For more Chalk Talks, check out the on-demand section of eejournal.com.